Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science. And in this video, we're going to do some examples with reference angles. So what are reference angles? Well, they're basically acute angles that help us figure out information about more complicated angles. So let's go ahead and talk about what reference angles are in general, and then we'll talk about how to find them and do an example. So for reference angles, we're going to have our x-axis and our y-axis. So remember, reference angles are acute angles, so we're going to be talking about angles in standard position. So that means vertex at the origin and initial side on the positive x-axis, okay? And the terminal side is going to be in one of the quadrants. So we're not going to talk about reference angles for angles on the axes, but just for angles in one of the quadrants, okay? So in the first quadrant, the reference angle is just the angle itself because that's already acute, okay? So that's good there. Now in the second quadrant, okay, so in quadrant 1, put it this way, in quadrant 1, the reference angle is just the angle alpha. All right, so now let's say we're in quadrant 2 and we have our angle alpha here. Now the reference angle is going to be this angle right here. So what is this angle? Well, this angle right here is alpha. This entire thing is 180 degrees, right? In other words, pi. Let's go ahead and talk in radians. This whole thing is pi radians. So if we take this entire thing and subtract this, then we're going to be left with this, right? So in quadrant 2, what we have is, in quadrant 2, the reference angle is pi minus alpha, okay? So if this is alpha, this whole thing is pi, then this guy right here is going to be pi minus alpha. Okay, so again, pi for the whole thing, subtract off this piece right here, and what we get left, what we have left is this piece. Okay, so what about in quadrant 3? Whoops, I guess we're stuck with that. In quadrant 3, let's go ahead and make a new coordinate axis. So x-axis, y-axis. If our angle alpha is in quadrant 3, we're going to be down here somewhere. So we're going to have this. So here's our angle alpha. Now the reference angle is going to be this angle right in here. Okay, so the reference angle is always the angle between the terminal side and the x-axis, the closest part of the x-axis. So in quadrants 2 and 3, the closest part of the x-axis is the negative part. So that's why the reference angle in quadrant 2 is this angle here. And that's why the reference angle in quadrant 3 is this angle here. Okay, so what is that angle? Well, if this whole thing is alpha, and this piece right here is pi, then how do we get this piece here? Okay, so it's going to be pretty similar to the reference angle in quadrant 2, but just pretty much switched. Okay, so in quadrant 3, we're going to take the entire angle alpha, subtract off just this piece, which is pi, and then we're going to be left with this piece. Okay, so again, take the entire thing, get rid of this part, and what we have left is this. And what we have left is exactly our reference angle. So in quadrant 3, we take the entire angle, subtract off pi, and what we have left is the reference angle. Okay, so in quadrant 3, the reference angle for the angle alpha is alpha minus pi. And then finally, what about quadrant 4? So we'll go ahead and make a new picture. X-axis, y-axis, and then our angle is going to be in quadrant 4 going around this way. Okay, so then what we're going to have is this is our angle alpha, and then our reference angle is going to be this angle right here. This angle right here. So how do we get that? Well, we know that if we go around the entire thing, what's that going to be? That's going to be 2 pi. So if we go around the entire thing and subtract off just this piece, then what we're going to have left is this piece. Well, what is this piece that we want to subtract? It's alpha. So in quadrant 4, the reference angle is going to be 2 pi minus alpha. Okay, so if we go around all the way, that's 2 pi, subtract off just this piece, okay, subtract off just this piece that ends right here, then all we have left is this piece right here. And this piece right here is exactly the reference angle, which is exactly what we want. So go around 2 pi, subtract this piece, which is alpha, 2 pi minus alpha, and that gives us our reference angle. Okay, So this is how we find reference angles in the four quadrants, and this is provided that alpha is between 0 and 2 pi. Things do get a little more complicated if we're going around multiple times, but then in that case, what you could do is just use coterminal angles to eventually get some angle between 0 and 2 pi. Okay, so for example, if we were to wrap around 3 times and then stop at this point right here, we just know that if we wrap around backwards 3 times, we'll be at that same point, and then the reference angle will, in this case, actually be the angle that we stopped at, for example. Okay, so again, these 4 right here are assuming that alpha is between 0 and 2 pi, and if alpha is not between 0 and 2 pi, just use coterminal angles. In other words, just wrap around in the positive or negative direction as many times as you need to until you get to something between 0 and 2 pi. Okay, let's go ahead and do an example. So let's say we want to find the reference angle for, let's go ahead and say 8 pi over 7. For 8 pi over 7. Okay, so actually let's go ahead and change that to 10 pi over 7. Let's say 10 pi over 7. All right, so what we have to do is figure out which quadrant is 10 pi over 7 in, then we can use these here, okay? Now we know 10 pi over 7 is between 0 and 2 pi. We can check that. Is 10 pi over 7 between 0 and 2 pi? Now we can toss this into a calculator and verify that it is between 0 and 2 pi. Okay, or what we could do if we don't have a calculator handy, or if we're not allowed to use one, what we could do is say, okay, well, 0, of course it's greater than 0, right? This is something positive, so of course it's greater than 0, so that's okay. But what about 2 pi? Well, 2 pi is if we multiply the top and bottom by 7, so let's multiply this by 7 over 7. That's going to be 14 pi over 7. And this is greater, 14 pi over 7 is greater than 10 pi over 7, right? Because of course 14 is greater than 10, so if you multiply by pi and divide by 7, everything stays the same. So this actually verifies that 10 pi over 7 is greater than 0 and less than 2 pi. So yes, everything's fine. 10 pi over 7 is between 0 and 2 pi. So we're okay there. So yes. And again, we want to check that because remember, these formulas here only apply if alpha is between 0 and 2 pi. Okay, so let's go ahead and figure this out now. So which quadrant are we in? So x-axis, y-axis. How do we figure this out? Well, we know that this is the angle 0. Up here is pi over 2. Let's go ahead and draw that a little better. Up here is pi over 2. Okay, that's pi over 2. And then over here is pi. This is just plain old angle pi. And then down here is the angle 3 pi over 2. And this is all assuming that we're going around in this direction here, okay? Now, where does 10 pi over 7 fit into all this? Well, what we can do is get 10 pi over 7 and this pi over 2 and pi and 3 pi over 2, get them having a common denominator. So let's go ahead and be a little more careful though. If we look at 10 pi over 7, we can say, okay, well, that's 10 over 7 times pi. Now 10 over 7 is clearly greater than 1, right? Because 10 is larger than 7, so of course 10 over 7 is greater than 1. So what that means then is that 10 pi over 7, so 10 pi over 7 must be greater than pi. Okay, so we know 10 over 7 is greater than 1, multiply both sides by pi, and you get this inequality here. So 10 pi over 7 cannot be up here, and it can't be up here, okay? So it has to be in here or in here. So basically all we have to do now is compare 10 pi over 7 to 3 pi over 2 and see which one is larger, okay? So let's go ahead and do that. So we're going to get rid of this now. Now, how do we compare 10 pi over 7 and 3 pi over 2? Well, the same way we would compare pretty much any type of fraction, just get common denominators. So even though we have a pi there, the pi is really not making anything that much more complicated. So all we have to do is say, okay, 10 pi over 7 times 2 over 2 is going to be 20 pi, that's a 20 pi over 14. And likewise, for 3 pi over 2, for 3 pi over 2, we can say, we can multiply that by 7 over 7. And that's going to give us 21 pi, okay, because 3 pi times 7 is 21 pi, over 14. So 3 pi over 2, this is 21 pi over 14. The angle that we want is 20 pi over 14. So actually 10 pi over 7 is just ever so slightly less than 3 pi over 2. Because 10 pi over 7 is 20 pi over 14, 3 pi over 2 is 21 pi over 14. 21 pi over 14 is bigger than 20 pi over 14 because 21 is bigger than 20. So what that means then is that 10 pi over 7 is somewhere right about here, roughly. Okay, so here is 10 pi over 7. So what that means then is that the reference angle is actually this acute angle right here. And how do we find that? Well, again, we're in quadrant 3, so our reference angle is going to be alpha minus pi. Okay, so all we have to do now is evaluate 10 pi over 7 minus pi. And then we can multiply this by 7 over 7. So this is, let's go ahead and fix that. This is 10 pi minus 7 pi all over 7. 10 pi minus 7 pi is 3 pi. So 3 pi over 7 is our reference angle. Okay, so this might seem very complicated, like it's a lot of work, but that's only because I was explaining all the details, and because we, before we started the example, we went over how to find reference angles in each quadrant and talked about what to do if we don't have an angle alpha between 0 and 2 pi. Okay, so, but the actual process of finding the reference angle is really not that bad. All you have to do is just look carefully at the angle that you have, think about how does it relate to pi, and then that could make it easier for you so you can pretty much knock out 2 of these quadrants right away after you've already verified that your angle's between 0 and 2 pi. So those would pretty much be the steps. Is first, verify your angles between 0 and 2 pi. If it isn't, use coterminal angles, which means add and subtract 2 pi as often as you have to until you get something between 0 and 2 pi. And then compare your angle to pi, if possible, which it should always be possible, it just might not be easy. But compare your angle to pi, and then right away you can knock out 2 of the quadrants. And then finally, compare your angle to pi over 2 or 3 pi over 2, possibly getting a common denominator if you have to. Okay? So, and then remember, use these formulas here once you've done that. So this has been an example of finding reference angles, along with an explanation of how to find them in general. I hope you found this video helpful, and thank you for watching.